Okay, Greg, Rick, you two are on the line, and we have about 100 people listening to you, so no pressure. So this is an update on the efforts for the OpenSFS benchmarking work group. My co-chair is on the line, and I'm going to make this fast. This is the last session of today. So before I start, I would like to have Ben Evans, Soren, and Pietro, and Andrew Wesselton. Could you guys come to the stage so we can do this fast? We don't have to stop again. Okay, while they are settling down, this is our third face-to-face meeting. We had one at LUG 12, we had one at SE 12, and this is the third. Apparently, SE and LUG is roughly 6 months apart, so this gives us a chance to do semi-annual face-to-face meetings and do course correction and get up to date on what's going on. And business first, we are having bi-weekly con calls on Fridays at 11:30 a.m. Eastern. So if you enjoy what you see on the slide deck, or if you are interested in what you will hear in next hour, please do dial in and join us. The dial-in number is there, the passcode is there. Our next meeting will be on May 3rd, 2013. If you are phone shy, if you don't want to talk to us, but if you want to keep track on what's going with the email is listed over there. To join in, the URLs are given in the slide deck. I'm hoping these slides will be online, so you can follow the links. So this is what I did this morning. Write down all the institutions that one way or other have participated in the benchmarking work group effort. So I have 25 institutions or companies actively participating in our effort. I thank you all of the representatives for these institutions, companies, for their efforts, time spent on these. And again, I just talked to Craig from University of Florida. Hey, they might be interested in what we are doing as well, so we might be still growing after this point. So please do join in. So what we have done, we had a face-to-face meeting that was our last at SC12. We have re-established our goals, and we have discussed what we have done up to that point and what we will be doing up to this moment. And our two accomplishments, the first is we released our IO benchmark, IO workload characterization survey to the public. If you have never heard of it before, it's our fault. It's still on the web. If you want to spend some time parsing through your file system and providing our some data to us, you are more than welcome. So far, we had 5 responses. Arctic Supercomputing Center, us at Oak Ridge, Nix at Oak Ridge, STSC and Fujitsu. So it's not a big set for the whole. It's not a big set for the whole community, but at least it's a starting point. And we have started our benchmark characterization effort. Since SC12, we have finalized both of these efforts. At SC12, we had 4 goals listed as what we should be doing up until this point. We should provide a mechanism to obtain a hero performance number for a parallel file system. We should provide a mechanism to obtain workload-based performance numbers from a parallel file system. We should provide methods or tools to monitor a parallel file system. And we should provide methods or tools to assess and evaluate the metadata performance. So these were the 4 mandates the benchmarking workgroup community provided back to us at SC12. What we have done to follow this up, we have formed 5 task groups under the benchmarking work group. Block IO Hero Run Best Practices effort, IO Workload Characterization effort, Application IO Kernel Extraction effort, Methods or Tools to Monitor a Parallel File System effort, I know that's a broken sentence, Metadata Performance Evaluation effort. So we have 5 focused task groups to follow each one of these tasks. We already started making progress, and this will be the first time the whole community will hear about this. So here are the task leads. Actually, we have a 5th task lead, Eileen Carpenter from NREL. She's not here. Pietro will take over her portion and go through the slide deck. Everybody will introduce themselves. We are short on time, so I'll advance with the slides when you say so. Let's keep going. First, Block.io Hero Run Best Practices. Team lead is Ben Evans from Terrascala.
Hi.
Hi. There's a microphone over there.
Okay, but I can't see the slides.
Oh, okay.
Hi. We've been working with all of these people. Mark Nelson, Eileen Carpenter, Rick Roloff, Nathan Ruttman, and Liam Forbes. And what we're trying to do is come up with a number, some sort of hero number, like to generate a top 500 list of file systems. And we set out kind of looking for what we're, put some boundaries around this. One of the things we tried to do is say, reduce the amount of benchmarking shenanigans that can go on. As people who have all run benchmarks, we're all good at faking numbers. If you want to generate IOPS, you can always run a client that does write 4K, seek back to 0, write another 4K, seek back to 0. Get as many IOPS as you want. But from that standpoint, we're trying to do one of the things we've pretty much decided on is that the file system configuration, if you're going to do a hero run, should be configured as it's used in production. If you want cache mirroring turned on or off, if you run with cache mirroring off in production, great. If you want to run it both ways and find out which is faster, that's fine, but you're only going to publish the one as you have it in production. We wanted to have several sections of tests, read and write streaming, random I/O, single file or file per process, and then formulate the results from all of that into a single hero number. What exactly that formula is, how those results are balanced, we're still kind of working out. As I said before, the tuning limitations, the hero number is meant to cover everything from an NFS server, to a giant Lustre file system, Ceph, GPFS. We're not trying to be specific. We want to have, we want to be as all-inclusive about this as possible. So with that in mind, we don't want to go about itemizing things you shouldn't do. So we're just going to say, run it as you run it in production. Defining tests, streaming, random, file per process, single file. Probably not going to include metadata in there. And then, as a methodology for performing tests, simply start ramping up the number of clients and the number of threads until you hit your peak number, whatever that is, and record that. Because every installation is different, every file system is going to be different. But the key here is you want to have a sustained throughput on the file system servers. It's not well, I burned through all of my cache in 10 seconds, so I'm going to record that 10-second blip as my peak. It's your, sustained throughput over periods of time. And then take the results from all of those, crunch it down into some formula, and spit out a number.
That's it.
And that's it.
Okay, thank you. So we have Pietro from SDSC for IO workload characterization task.
Hi, I'm at SDSC since a couple of years ago. I'm in the performance modeling and characterization lab, and I'm also part of the Gordon project. Gordon is one of our machines that has flash drives and is attached to our Lustre file system. And that's when I started looking into file systems and Lustre in general, so I'm relatively new to, in this community. So as part of this effort, the members are me, Eileen Carpenter, Rick Moore, UTK, Mike Booth, HPC Results, and Ben Evans, Terrascala. So what we're looking at is understand what the workloads are in typical Lustre settings and try to identify and characterize a set of synthetic benchmarks that can reproduce those workloads for any kind of performance testing or testing in general. Part of what we do, it's overlaps and is strongly correlated with other efforts that you're going to be hearing about, in particular the I/O kernel extraction and the monitoring. Sarp mentioned we sent out a survey and we got some responses from a few centers, and you can see there's each center has one or more storage infrastructures, and those serve one or more file system. They range from hundreds of terabytes to a few petabytes, the K computer being the largest one, up to 30 petabytes. And as far as application, for the most part, it's just mixed workloads, except for the Arctic region supercomputing center that has a more specific workload. But for the most part, it's just very kind of heterogeneous workloads. Some stats here. This was, I guess, an animation. Here it's all in one place. But starting from the top, each file system serves hundreds to thousands of users, and mostly is 1.8 version, except for the Arctic region one. That's a 2.1.2 on the server side. Most of the interconnects is IB, DDR or QDR, Cray, C-Star or Gemini, and then there's Ethernet, Mirinet, and the Tofu interconnect for the K computer. We looked at the size, and they all have millions of files. Now, if we look at the distribution of the size of the files, normalized by the number of files on each system, except for some outliers, and that'd be nice. I mean, with the survey, there's no way you can go back and see why you have some of those, but for the most part, you can see that it's a large number of small files, and that's common to all the centers. And in fact, if you look for all the centers, more than 90% of the files are 4 megabytes or less. And if you look at the average, actually that's 90% of the files are 2 megabytes or less. If you look at the capacity, meaning how much all those files together account of the storage, still all the curve is shifted to the left. So most small files account for the storage that's used. In fact, 90% of the capacity is used by files that are 2 megabytes or less. This is looking at the size of the directories. That's the number of entries. Most are small, obviously, few files, all below 200 files, and that's common across all the centers. And again, if you look at the capacity, it's the same story. So how big are the directories? For the most part, less than 8K. And so that's essentially a very large number of directories and a very large number of small files. And this is looking at the two together. What next? We haven't looked at the timestamp on the files, for example, how old are the files, how often they're reused. And that's data we have from the survey. We will be looking at that and summarize all the observations into a report. It'd be nice to engage with one or more centers to actually go back and look at some of those outliers and understand what's going on. But even better, look at the dynamic workload. Because one thing is look at this, like if you get that data, that's basically a snapshot. But it's very different understanding what happens in the day-to-day environment. So we will be looking at existing benchmark and try to reproduce most meaningful workloads and create our own tools in collaboration with the kernel extraction effort. And that's it. If you have.
Thank you, Pietro. And
well, I can continue.
So
this is, I'm not Eileen, so it's still me. So that's for the application I/O kernel extraction and creation effort. I'm also part of the team together with Jeff from Dell and Bobby Lind as of yesterday from Intel. So basically we want to start looking at applications and extract their I/O kernel. When possible, just do that directly on the application. If there are gaps or we feel there's patterns that are not represented, create new kernel to mimic that behavior. Looking at the range of small to large jobs and systems and high throughput computing. Obviously, the kernels themselves are not necessarily tied to Lustre. They're just general tools, and they will be open source, so used to test any I/O system. There's a few out there that we will be looking at that are representative of a specific application workload. We will try to extract more from applications when it's possible, directly from the application when it's not possible, either because the application is not available or it's not available for some reason. Classified, for example, just try to collect all the data we can from the outside on the system anyway, and try to use that to recreate the workload. Of course, we'll try to use those, make available all the scripts and the documentation for using those, and collect statistics, and hopefully have users that use those and gather that statistics from them. So we welcome input and feedback from all the community. In fact, we would like to hear especially about workloads that don't play well with Lustre and that are, can cause poor performance. And that's it.
Thank you. So next, we have Andrew for the monitoring effort.
Hello again. So that's the gang. We wanted to lay out more of a framework on which we would hang information and then just start building information into that, and putting it into the PowerPoint is a reasonable first place. Maybe put it on the OpenSFS website at some point. So why would you want to do monitoring? What are the use cases? What sort of things can you monitor? What are the tools that are out there for gathering and then also for presenting? So the questions on the right and then the sort of bullet points on the left. So you might want to monitor just to see what is happening right now. You may also want to get some sort of gestalt about, how does this file system run in general? So you might do workload analysis on it. If somebody calls you up and complains that, Lustre's horrible, it was doing really badly last week or yesterday or whatever, you might want to have some monitoring data you could go back to and see if you can get some insights into what was happening. And then also, when you're doing the real-time, looking at the real-time view or looking back at data, you might see something that just, what in the world was that? And so you may want to go and investigate that. And if you're not gathering the monitoring data, you wouldn't have an opportunity to do that. So the kind of data sources you might have are certainly the Linux proc, Lustre proc, and you can also visit the RAID controllers. Some of them have APIs so that you can harvest data. And then obviously benchmark tests. You can think of, especially Katie Antipis at NERSC does a regularly scheduled small IOR like 3 times a day. And so after 1,000 instances of that, that stops being just a benchmark, and that's now an actual tool for monitoring what the file system is doing, because you get different numbers out of the live production file system after 1,000 samples. And there's other data sources. We'd love to hear from you if you've got ideas about other data sources you'd like to collect. What sort of tools are there? Obviously, I'm very involved with the Lustre monitoring tool. Ganglia is really a transport mechanism, but Collectel and Ganglia gets used, so Ben has looked at that a little bit. We're not going to go into a lot of detail with each one of them, but we list a nice collection. A special note down at the bottom, Richard pointed out to me that XLTop is the latest thing from John Hammond, who's now at Intel, I guess. And that looks interesting. I haven't played with it, but he gave me a demo of his earlier version. It was really good stuff. So this is just giving you an idea of what the Lustre monitoring tool itself will do. You can get read and writes bytes per second and several other parameters. Collectel, again, what can you get? Presentation tools. There isn't a lot in the way of presentation tools. And so for the Lustre monitoring tool, there's for looking at real-time data, you can use just LTOP or LLTOP, John Hammond's LLTOP or XLTOP. And that'll tell you that's a presentation tool at the, it's an ncurses, and it's what's happening right now. So for certain purposes, that's perfectly good. Otherwise, if you want to present this information, you really have to figure it out for yourself. There isn't really, and I've written a bazillion, little presentation scripts. There is a system called Cacti that I am not deeply familiar with, but somebody else at NERSC does use it, and so I've sort of poked around at it. And it's a way of sort of presenting stuff. The information comes from somewhere else. You have to instrument it, and then you feed it to Cacti, and it's got 10,000 graphs that you can wander through. So that's what we're doing.
Thank you. And we have the metadata performance evaluation effort, and sorry.
So first of all, just to introduce myself a little bit, you know me already, but I have another hat that you may not aware, and that's why I'm presenting this. I'm a member in the SpecSFS committee, so I work closely with the benchmarks for NFS. So this is our team: Branislav, Richard, Cheng, and Wang. We don't know yet who will be more active, but they're both in the group. Keith and Bobby from Intel, you saw her here, and Greg from Intank. What we want here is a little different than the other groups, because we were not talking about hero performance. We're talking about maybe performance, at least in the Lustre case. It's very important the metadata becomes maybe more actual important than it was in the past, and we believe that there is a need to do some work in the tooling thing. We want to build tools that will detect pockets of metadata performance that will be able to characterize the storage system when it was procured, but also to troubleshoot issues while they happen. And we are looking to support POSIX, MPI, and transaction operations, CEFs and DAOs. I'm not sure if for CEFs it's relevant, but for DAOs for certain is. And we'll address the very high-end HPC as well as not so very high-end and the small and medium installations, because the metadata could be a problem for all. The data, maybe you buy a more performing storage system and you know what you're buying, but metadata could create problems later. And we believe that the tools should be applicable to Lustre and any other file system, so we don't take sides. So we selected the initial test of group of tools that we are familiar with, and of course this is not all, and we expect the support of you guys to tell us what are you using. And of course, MD-Test already saw several presenters discussed about that. FS-Test is a tool that I know it's used for PVFS, and it has a lot of flexibility for the metadata operation especially. Postmark and an MPI version that we are using in our test is also was and is still very popular with file systems metadata testing, and we believe that our MPI version will export the value which is used for Linux file systems to parallel file system, Lustre, GPFS, others. NetMist is a new tool that maybe you're not familiar, but we built, it's the next SpecSFS 2014 maybe, benchmark, and we have a special version which is actually open source, and it's only for the benchmark of parallel file systems. And we'll discuss a little bit what value it brings. Synthetic tools like you all use are important, and we'll want to hear from you what are you using. So we have a larger, wider group of benchmarks to select from. MDS Survey, Intermetadata Workload Simulator will be also one of the tools that we're considering in order to generate workloads similar to whatever NetMist is doing. And we are looking to select any open source metadata tools used in HPC. And we are going to select a small number. We're not going to select 10. We're going to select probably 1 or 2 or 3 that could be representative, yet it could be that people having experience with a specific tools on a specific bad case of performance of metadata, it's always to be considered, and we'll keep a list of tools on the OpenSFS website that will allow people to try maybe if the tools that we recommend are not good for the workload. And I assume that Sarp is one of them that will say, no, I want this. So I tried to put some use cases, but I'm not sure that's a good definition, but that's something that I wanted to share. Maybe people will understand the value of each tool even though they're not using them. So MD-Test is very popular, and at least in the academia, and so we believe that it's a very good tool for counting operations like open, create, lookups. And is popular, as being popular is very good because you can compare to maybe you don't have another file system, but people are publishing papers, and you can compare by looking what others, the similar architecture of Lustre or similar configuration did. So I think it's value. It's a good value in that. Maybe it needs to be modified like Bruno did. We agree, and we could do the work. Of course, we need first to analyze to see which tool does what. So FS-Test, from my experience, I was using it intensively, and it's a very powerful tool. It's not an MPI version. It's only POSIX, but it gives you a very good flexibility in deciding the structure of the metadata directories, inode size. It has value for different size of the file name, for example, which is sometimes a problem. So I think it's a good tool to consider. Maybe it's not the perfect tool, but for certain operations it's good. Postmark, probably you all already know about it. I'm very familiar. I ran a lot of Postmark on local file system on Linux. And you know, even compare with that is very important because you can realize how a distributed file system, a cluster file system, could compare to a JBOD or, you know, like other. And NetMist, which the value of NetMist in my mind is, first of all, we implemented the MPI version of it, and You can, we'll try to run it actually on the Indiana University, and we'll probably give you some results. The good news, good value of Postmark is that you can create your own object, workload object. So you can, if you have a specific workload which is not similar to others, if you can get statistics and look at it, you can model an object that will behave exactly the same. So that will give you the flexibility of creating your own. So in case that, for example, when you build a system, you start and test it and create an object, and then you test this object periodically, and then you figure out if something starts to change to the worst. Again, there will be documentation, and everybody can look at it, but just in a few words. So what we want to do, we want to collect many benchmark tools that people are using, because if, I have my own anecdotal about Lustre, Lustre is like the courtyard of Harvard University, About 5 years ago, they put new grass, and they didn't put any path. So a year later, they put a path wherever the people walked. So I think that's what's happening to Lustre, so we want to follow the model. So, and we're very happy about that, by the way. We want to evaluate all the tools. We won't burden people with evaluation. We'll evaluate it, but we want to collect as many so we can make a recommendation about which one is the most important and most valuable. We want to collect statistics from users as much as we can related to metadata operations, so we can model our tools to cope with different cases. Build scripts. Again, I don't know exactly how much work we could put in this, but we'll try. And write documentation, troubleshooting, and as I mentioned, our goal is to help the IT departments when there is trouble with metadata to figure out why. And of course, we need your help. So,
that's it?
Yeah.
Okay, thank you. So, that was the update on 5 tasks we have. We might be driving to the cliff. We have no idea. We might be doing the right thing. You are here to tell us that. If we should be doing something more, you let us know that. If we should abandon any of the activities we are doing, if it seems utterly stupid to you what we are doing, please let us know that as well. We have, I think, 10 more minutes. I'll open the floor for questions, but before we do that, we are not trying to brand anything as what should be used by the community. What we are trying to do is learn more about the workloads, how we do monitoring or benchmarking, what tools we use, document it as much as possible, and give it out to the community. And if community wants to use it, that's great. If community thinks something else should be used, that's also great. But we are in part trying to educate the community, in part trying to come up with best practices on how to attack some of these problems, what tools to use, what should be the arsenal attacking some of these problems. That's all. We are not trying to do anything beyond that. So, having said that, are there any questions?
This is regarding the hero benchmark. Rather than using a formula, why not run all the benchmarks simultaneously in some balance of file size or time?
Yeah, the question was, rather than run all of the benchmarks separately and then aggregate them into a single number, why not run them all together and see what happens? You have several contradictory benchmarks there, like streaming and random. That would mean you have a random benchmark. But again, all of this is just kind of off the top of our heads at the moment. It's a work in progress.
By definition, hero number doesn't give you that. Hero number is the stellar numbers where all the planets are aligned wind is blowing on your back, etc. Hero number is that. It's not anything beyond that. So
It's the ultimate peak benchmark.
I/O workload.
Then don't do small file I/O. Don't include that if that's what you want.
Okay.
But small
fine.
file I/O is one case. You know, you can have a file that, or a file system that is much better at small files than Lustre is. How do you compare the strengths? This is kind of a allowing for strengths and weaknesses between file systems. You know, if you have a file,
Using a formula doesn't. Using a formula then takes any meaning out of it whatsoever.
So we have limited amount of time. You have seen our meeting times and email list, right? So join us, raise concerns, and correct us.
So one comment, kind of also in that same realm. There are certain characteristics of good benchmarks, and one of those is proportionality. The other one is that benchmark should be proportional to the time to solution for whatever problem you're trying to represent. So I'd urge you, as you put together these benchmarks, particularly if you're going to do something like a list, and some may know that I have some opinions on lists recently, that you really pay attention to how they relate to time to solution. That is really the only measure of real sustained performance, and what you do should be proportional and directly related to that.
So I completely agree with the idea that you should get some set of metrics that allows you to characterize the system. But one of the original sort of ideas behind this effort, when it was kicked off, was that you'd be able to compare sort of different vendor solutions on a level playing field. And I'm wondering if that's actually happening here, because what I seem to be seeing is things that will let you compare different people's installations, you know, the final solution including the whole machine. And I'm wondering if there's any support here for, you know, making the choice before you've bought the actual, for example, a scalable unit benchmark.
So if I remember correctly, our mandate was never to compare vendor solutions. Our mandate was to provide tools, and if the vendors wanted to use those tools to compare each other, that's their business. OpenSFS boards clearly dictated several times that they want to be vendor neutral, and they didn't want to give any baseball bats to beat any vendor on the other side. So we are not doing that. If vendors can use what we provide back to the community at the end of this effort to compare their solutions to one another, that's it. I might be totally misunderstanding what OpenSFS board told us at the time, and if that's the case, there's a board member smiling at the back, and he should let us know now.
Yeah. Sarp, from my point of view, having a benchmark, whether OpenSFS is actually actively publishing results or not, maybe that's a separate issue, right? But having something, you know, sort of the hero aggregate number, you know, whether it's combined together and you get the individual results later to compare, but saying this would be a good thing to compare vendor storage, I mean, that's useful for customers. That's useful for the Lustre users, right?
True.
And so, you know, I think that that's a reasonable thing to say, as opposed to, well, here are 100 benchmarks that you might find useful, right?
We are not trying to list every benchmark and describe them that's under the sun there. We are trying to come up with, these are the benchmarks, a few of them, very few of them, for the hero one. At least that's my understanding. Bank can correct me.
Or maybe it would be worthwhile inviting into the hero benchmark group getting a representative of, each of the major, Lustre storage vendors, and everybody can agree on something, and then they would start publishing those numbers so that their customers can compare,
They're all perfectly welcome to join.
Yes, this effort has been going on for a year and a half. I mean, we didn't close our doors to anybody. NetApp is there. Intel recently started putting some effort there. I know, I'm saying vendors, not storage vendors. EMC is there. We didn't close doors to anybody. If you want to join, if you want your voice heard, that's fine. I mean, if the vendors leave us in the void, this is the best we can do.
So just one comment. I think that the best thing will be to present the users with a set of benchmarks with specific use cases, and they should ask the vendors to run specific, if their workloads fall in that specific category. That's why I do it with the customer, right? If my workload is not random or something, I would, So that's what we want to do, not to compare.
But just like, you look at a graphics card or something like that, and you can look on the internet and find some numbers that compare the performance of 10 or spec int or whatever for your chip. It's not like you want to go through and the vendor reruns these benchmarks and you have to ask each vendor to rerun everything. It would be convenient to be able to say, this is my Lustre mark result for 32 clients against our scalable unit, and then you can compare the Lustre mark for, the NetApp 5460 or whatever, and the DDN SFA 12K, and whatever other, bits of hardware. So then you can make a reasonable starting point as a user for what to look at.
My point is that we cannot be the judge. We can just create tools, and users will ask for a specific thing. That's what I'm saying. That's what we're trying to do. But maybe you're right. Maybe you should have something that can be published and people can compare. I don't know. That's something that the whole group needs to decide.
I mean, this is not the first time we are discussing this effort. This has been discussed, put to shelf, then discussed again. We are going back and forth on this one. And at some point, we decided we will provide our understanding on the benchmark tools. And we will not try to brand any of them as this is the OpenSFS benchmark. We won't try to do that. We will just put out what we think is useful for certain workload cases. And as Soren said, that was the collective understanding of the group. If someone wants to use that based on our guidance and documentation, that's good. But if the community is expecting more to be done by the benchmarking work group, and if the board approves it, we are more than welcome to follow that direction. You just provide us feedback. That's why we are here. I mean, if you think what we are doing wrong with the Hero benchmark effort, and I think there are concerns coming from multiple parties, we should revisit that. But we are acting on the last guidance that was provided to us. Any other questions? Okay, so I'm wrapping this up. If you are interested in our effort, please visit OpenSFS website. You'll find our con-call information. You'll find how to join our mail list. Our next face-to-face meeting will be at SC 13. So we are trying to do this every 6 months. You can join in our con-calls. You can drop us an email. You can just come to face-to-face meetings. But if you want your voice to be heard, just please engage with us.
Just one more point before we end up. And if you could provide us traces, it's very useful. And we know we discussed this and we asked individual users, but maybe we can ask for everybody to give us some.
True.
That was our biggest fight, right? The whole year, right? Actually, to get some.
Any IO traces, any new responses on the workloads characterization survey. Anything that you can provide us that will guide us, that we can use, that will be great. So this is all we can do in a vacuum. Help us, we can do better. Thanks.